questions in a very autistic way, so to speak. So I very quickly go through that, and then I give you some feel of what we do with your technology.
Okay.
So basically, you ask who we are and so on. So we are a Belgian company, about 18 staff, 4.5 million euro of revenue. We work in the Benelux area, but we do develop niche applications for large-scale metrology, for automated inspection and measurement-assisted production. And you will see the examples, what we do. So we focus on very large scale, so wind energy, cranes, also some applications in marine, railway, aero, but mainly offshore wind. This is our thing. So we hope from this meetings such as this to see, well, what other applications with the product tracker product line, because that's what we focus on. And we also, I will also give you a feel of some of the hardware and software components that we have developed along the line. So basically what we do is bringing large scale metrology also in line, but contrary or maybe different from what other people have mentioned here is that we do not use robots. And we feel that certainly your newest tracker product, the ATS 600, is like automation without a robot, and you will see how we are using that. Basically, yeah, we see when you don't use a robot, of course, you need to have a stable localizer, a fast instrument relocation. With the robot, you can move the instrument very quickly. So we are working on that, and we were looking, well, maybe other people are working on that as well. So I will show that later on. Also, we are an integrator. So basically, we say on the one hand, it's about 1/3, measurement, and 2/3 is integration. So having a good sensor, which Hexagon offers, that's good. But to actually then do the programming, the software, the custom toolings, analysis scripts, and so on, and project management support, that is to bring metrology to the shop floor. That is the 2/3 of integration work that you need to do. So what do we do? We focus very heavily, and I give you examples on the wind sector, going from the blades to the nacelle to the supporting structures. And our aim is to develop we are developing solutions and roll them out worldwide. Starting, of course, in Europe. We are a small Belgian company. And we have developed to enable this. We have developed two things. On the one hand, we have developed what we call a measurement vehicle. This is one of the one version where you see here an ATS 600 with like an adapter that we click, as it were, on a stapler, a logistics stapler that we modify slightly to make it more robust and more stable. And in that way, you can bring this as a device on the shop floor. I'll give you an example of some of the things that we do. So, for example, our idea is to develop these niche applications. One niche application is for cranes. So these are these telescopic cranes, often also used in the wind sector or in construction, that go up to 100 meters high. So basically, the components to measure those, up to now, there is one GOM installation somewhere in Germany, but other than that, people use very basic methods to measure it, so like a caliper or a rolling tape and so on. And so we have brought an innovation where we put the ATS on a trolley so that you can easily do the instrument relocation from high up on one side. We then lower it to the other side, and then we go with the trolley to the next side. And in that way, we can measure such a beam, a tube, in 10 minutes, including relocation. And normally, traditionally, if people think if they need to relocate the tracker manually, it takes a lot of time. So with this thing, it goes very quickly. It's a couple of minutes to relocate this tracker from one position to the other. And basically, apart from using the geometry of the tubes, we can also use the device to check the completeness. So here on the left, you see also the device as a touch screen to operate it. So one of the speakers earlier on said, you reduce the cognitive load. You reduce the cognitive load of the operator. We call it a coffee machine principle. Our system is as easy as using a coffee machine, and that is how we try to bring smart technology onto the shop floor. So this is an example, also a bit more information about our mobility system. So it's basically an upgraded pallet stacker, but also for windmill blades we use a reach truck. I will show you this one as well. So this is what we have done for what we are doing at the moment for wind turbine blades, where we use a reach truck where we go up to 10 or 12 meters high to measure the huge blades of 120 meters going up to 6 meters in cord length. So at the moment we are the company that is the first to have implemented such a system. We are implementing this now in India. This is with an ATS 600. So basically we are saying we are using automation. Okay, it's not fully automated. You still have to do some manual relocation. In the future, you can do that maybe with AGVs or so. But at this moment, it is still involved there is some operator interaction involved. Here you also see he's guided what to do by a human-machine interface that we have developed. And basically you then make sections of your blade. One last small application, for example, it shows you how we try to develop niche applications. This is not a huge market, but when you make transition pieces, these yellow pieces for wind turbines, you have a platform, and on that platform you have a lot of studs, and you need to weld these on the correct place. And it's not rocket science, but if you miss them out, if you put them in the wrong way, and it all gets painted and it's ready to be shipped, it causes a lot of headache. So customers are prepared to invest in tools to guide them where to position and to check very quickly. And this is an example of this was an 8500 where we are delivering now. This was a first test for the customer, a proof of concept, where we help them to position and to check in a very quick way, very easy. We make some smart tooling, and in that way we then have a mini application to allow people to speed up the production and the inspection of this type of parts quickly. So that is in a nutshell what we do. So we work mainly, we try to achieve automation not with a robot, but with an ATS 600 or also 8500 or whatever. So tracker tools, but the localizing, we try to be more creative in that and use standard or used vehicles from the logistics sector that we modify to be able to be used as a metrology device, so to speak. So that is in a nutshell, very quickly, what we try to do with the Hexagon technology. So automation or semi-automation in very large volume metrology. Is one question?
Yes, the first question from Axel.
Yeah, thank you for the presentation. What kind of what accuracy do you reach with your rotor blade geometry measurements for the profiles, and what measuring principle is your scanner?
So basically here you see the study variance. These are millimeters. So this is R&R studies that we did. Basically we use the ATS 600. ATS 600 specifies plus minus 0.3, but in reality, you see sometimes you do better. Sometimes, yeah, here so there's some local repeatability. The local uncertainty is often smaller. So we do see that depending on the feature that you need to measure, the flatness, global flatness on the root. Okay, that is measured with the SMR. So that's 0.16. So this is the root. This is the airfoil. So we have chord length of 0.6, blade thickness 0.2. Twist, okay, that's a global dimension, that's 0.03 degrees, and then local leading edge, downwind, upwind profile deviations. You see, we are 1/10 to 3/10 of a millimeter. So it all depends on what you need to measure. So it took us a lot of programming and algorithms to filter out the bad data. So it has taken a lot of research to come to such values.
Okay, thank you.
But we use the ATS 600, so it means ATS 600 is you can combine it, of course, with SMR measurements for more precise features. And for the scanning, it's I would say just accurate enough for this type of application.
Fantastic. Are there more questions? Otherwise, before we come to and I saw Alex Hiller left, we didn't catch him. We would have Christoph Brillinger as a last speaker. I would have also one question, and I plan to share this slide in the afternoon. Alex, if you could share something about this application directly from the expert. I think you were there involved as well.
Yes. So is it you asked me or?
Yes. Yeah.
Okay. So this is indeed also an application that we did together with Hexagon for Siemens Gamesa in Cuxhaven. So basically, the challenge is they need to assemble a stator in a direct drive for a direct drive generator. And you see 1, 2, 3, 4, 5, 6 up to 12. So 12 segments need to be mounted on a stator. Every segment is taken individually and mounted, and every segment weighs about 3 tons. So you need to position a segment of 3 tons relative to the rotation axis. And the rotation axis you can measure. What we do is we take the top flange. You see it there. Okay, later on he starts again. You see these 6 points on the the small circle at the top. There we take the reference, which means a plane, and we take also the circle, so that gives us the rotation axis. And then we work with a 3D Arena calibrated camera set, where the tracker then on the one end measures the reference of the stator, and on the other end then tracks he tracks the 3D Arena, so that the data of the 3D Arena are immediately reflected in the coordinate system of the stator. And in that way, you can then live track the segment. So basically, from a trial and error situation, and where they used photogrammetry, and each time so 1 hour, one measurement took about an hour. Now they have almost a live tracking of their segment. So it was a really beneficial project in terms of reducing increasing the efficiency of their generator production line.
And why not using T-probe? Why the 3D Arena?
Well, with T-probe, you have a person who has to you have a human hand that has to probe, and each time he probes at maybe a slightly different area. So the 3D Arena is like an automated system. So the customers, the operators, the only thing that they need to do is place the segment, look at the screen, and then reposition the segment a bit, and then do a bolt the segment, screw, tighten the bolts. Whereas otherwise you have a manual operation of measuring, and that introduces variation in terms of accuracy, and errors that people can make. So in this way, you have a fully automated, human independent measurement system.
Yeah. So you measure multiple times, multiple points at the same time.
Yes. You track 9 points, but of course they then correct each point set by set. So they know they have four bolts or so that they need to tighten, two upwards and 3 downwards and 2 downwards. And when they see the left corner at the top is out of tolerance, they move it until it becomes in tolerance. They tighten it, and in that way, they step by step they make everything green.
Yeah, fantastic. Thank you very much, Gert.